Okay, we're going to graph the tangent function. And to do that, we're going to begin talking about the quadrant angles on the unit circle. So I'm just going to build this with you. And if you'll remember, all these angles give us cosine theta, comma sine theta values. They don't give us tangent theta values, but we did practice either the quotient identity for tangent, excuse me, choked up, that tangent is sine theta over cosine theta. Or you might remember tangent was y over x. So we can get the tangent of 0. It's sine over cosine 0 over 1, which is 0. We can talk about the tangent of pi over 2. Sine over cosine is 1 over 0, undefined. We could do the tangent of pi, 0 over negative 1, which is 0. And we could say the tangent of 3 pi over 2 is negative 1 over 0, which is undefined. So that's important where tangent is undefined. We're going to look at this chart. Had we been together, we might make it ourselves. For these different x values, this is what we get when we do the tangent of those x values. Here is the undefined we just got at, I didn't talk to you about negative pi over 2. Do you remember how positive pi over 2 rotated this way, counterclockwise, and negative pi over 2 rotated that way? So this 3 pi over 2 is also negative pi over 2. So negative pi over 2 is undefined, and positive pi over 2 is undefined, and 0 is 0. And this pi over 4, just look at this one to begin with. That's the 45-degree angle where it's isosceles, and sine and cosine are the same. So the tangent would be that over that, which would be a 1. And negative pi over 4 is the same, except it's a negative 1. So we can build the tangent graph, and we are not as detailed as we are with sine and cosine. We build the tangent graph at negative pi over 2 where we're undefined. We have a vertical asymptote. That's how we show undefined. And at positive pi over 2, we're also undefined, so we have a vertical asymptote. I need you to do the midpoint between those at 0, be your x-axis. Negative pi over 4 would be halfway between these, and it's at negative 1. Positive pi over 4 would be halfway between these, and it's at positive 1. That's really all I need you to graph. I need you to start down here at this asymptote and hug it, and then come through kind of like a cubic function, and then you approach the other asymptote and hug it all the way up. That is one period of the tangent function of y equals tangent x. So if that is one period, then how long is the tangent period? It's between negative pi over 2 and pi over 2. So the period is equal to pi. For sine and cosine, remember it's 2 pi. But for tangent, it's just pi. Now the tangent graph isn't just this little swoop between those asymptotes. Don't worry about drawing this, but there are an infinite number of asymptotes. And that tangent curve repeats over and over and over again. That's the tangent curve, but we're only looking at one period of it. All right, so what do you need to know? You need to know the period of y equals a tan bx minus c plus d. You need to know the period is pi. If there is a b value, then we can find it using the period formula. And it's not 2 pi over b, it's pi over b. B is still the coefficient of the x. On sine and cosine, we put bx minus c equal to our left and right endpoints. Well, now we're going to do that at the asymptotes. So we have a left asymptote where bx minus c equals that left asymptote value. And we have a right asymptote where bx minus c equals that positive pi over 2 value. And that's basically all we need to know. So let's graph 1. Let's graph y equals the tangent of x over 2. Well, the amplitude's 1, and the b is 1/2. There is no c value on this one, and there is no d value. Let's see here. So since we have a b value, that means my asymptote locations are going to change. So the left asymptote is whatever the bx minus c is, equal to the negative pi over 2. And the right asymptote is when bx minus c is equal to positive pi over 2. Multiply by 2. So now we're at negative pi for the left asymptote and positive pi for the right asymptote. Draw those asymptotes. Get that midpoint for me, and make tangent be increasing. That's it. Oh, I forgot to check the period. If they had asked me for it, it would be pi over b. So we're going to keep change and flip. So the period's 2 pi, and that's what would be between negative pi and pi. All right, let's do another. Let's graph y equals 3, negative 3 tangent 2x, and see how it works. We have an a of 3. We got a negative. With our amplitude, that's a reflection on the x still. And we have a b of 2. We're not going to do much with the amplitude. It's how high and low it reaches, and tangent already goes from negative infinity to positive infinity. So we're just going to ignore it. It probably does make it a little more sharply increasing, but we're not going to worry about it. For the left asymptote, do bx minus c equals negative pi over 2. And positive. Instead of dividing by 2, I'm going to multiply by 1/2, just because the math is nicer. Multiply by 1/2. These are your new asymptote values. Negative pi over 4, positive pi over 4. And all I want you to pay attention to, whoops, that's not very spaced nicely. Oh, well, shoot, I shouldn't have messed with it. I do want you to get the midpoint, and since it's a negative, it's not going this way. That part's reflected and this part's reflected. So what it looks like is it starts here and it decreases the whole way. That's what the negative tangent looks like. And that is all we are talking about today with tangent. Although I do think they would have some midline shifts for you, but I don't see any. If if there happened to be a midline shift, like, then that would just shift the midline up just like it did for sine and cosine. We'd be up 3. We'd still have our asymptotes, but when we graphed it, our intercept would be on that midline shift, and it would be like this. So you might see one like that. Okay, that's all.